Hello friends, my name is Jayant and I study in grade 5. Welcome to my YouTube channel Maths with Jayant. I post math videos and through my videos I share the concepts with you. Today we are going to cover up a very important topic. Today's topic is divisibility rules. The divisibility rules of 2, 3, 4, 5, 6, 8, 9 and 10. So first let us understand what divisibility rules are. So what are divisibility rules? Divisibility rules are, suppose if there is a number like 345, or let's make it even bigger, 34,512. We are asked if this is divisible by 3. So now what does this divisible mean? Divisible means the answer. So if we divide this number with right over here 3, so the remainder should be 0. That means the number is perfectly divisible. Now what is this perfectly divisible? Let us understand. Suppose we have 5 balls. We have 5 balls. We have to divide these equally amongst 2 people. So how will we do this? We are going to divide it like this. 2 for the first person or person A and 2 for the person B. Now over here you see that this one is left over. This is the remainder left over here. We can't divide this further. So this means that 5 is not perfectly divisible by 2. So this is what divisibility rules are all about. For 2, for 3, for 4, for 5, for 6, for 8, for 9 and for 10 we are going to cover. There are more, but these are the basic ones. So now let us learn the basic divisibility rules. So now let us start with the basic divisibility rule. Our first divisibility rule. That is the divisibility rule for 2. So what is the divisibility rule for 2? Suppose there is a number, let's say 46. So if we are asked if 46 is perfectly divisible by 2. So how will we check this? We will not actually divide and check. That will waste lots of time. So we need to check if the last digit is 2 or 4 or 6 or 8 or 0. So that number is perfectly divisible by 2. Now let us even understand why it is. If we check the table of 2, so it's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We can even continue like that, 24, 26, 28, then 30 and so on. So if we check, the last digits will be 2, 4, 6, 8, 0, 2, 4, 6, 8, 0, 2, 4, 6, 8, 0. So, if this is the pattern, so this is why divisibility rule for 2 is this. Now let us check for a few other numbers if they are divisible by 2. Let's take the number 34. 34 ends with the 4, divisible by 2. 236 ends with the 6, divisible by 2. 4288 ends with the 8, divisible by 2. 3737 ends with a 7, not divisible by 2, because it should only be 2, 4, 6, 8 or 0. Now let us move on to the divisibility rule for 3. So what is the divisibility rule for 3? If we are given a number 69 and we need to check if this is perfectly divisible by 3. So how do we do this? We add the numbers 6 plus 9. So we observe that 6 plus 9 is 15. Is 15 perfectly divisible by 3? Yes. 3 5s are 15. So 69 is also perfectly divisible by 3. So we need to do the sum of the digits. And if the sum of the digits is divisible by 3, so the number is divisible by 3. Let us check. 3. 2 plus 4, 6 plus 3, 9. 9 is perfectly divisible by 3. So 243 is perfectly divisible by 3. Now let us have a look at another number. 7, 6, 1, 7. 7 plus 6, 13 plus 1, 14 plus 7, 21. Now 21 is perfectly divisible by 3. We know that 3 sevens are 21. So 7617 is also perfectly divisible by 21. Now let us just have a look at the last example. 5, 4, 5, 5. 5 plus 4, 9 plus 5, 14 plus 5, 19. 19 is not perfectly divisible by 3. So 5445 will not perfectly be divisible by 3. Now let us move on to the divisibility rule for 4. So what is this? If we are given the number, let's say 228, we need to check if 228 is perfectly divisible by 4. So have a look at the last 2 digits. Have a look at the last 2 numbers. So 28. If the last 2 numbers are perfectly divisible by 4. So the whole number is perfectly divisible by 4. Now if this is the case, suppose 600. Now the last 2 digits tend out to be zeros. What should we do in this case? If they are zeros also, then also they will be perfectly divisible by 4. So now let us solve 4, 7, 6, 4. 64. We need to check if this is perfectly divisible by 4. If you don't know, we can divide and check. So 4 ones are 4, we subtract, get a 2, then pull down the 4. 4, 6 are 24, we will subtract and we'll get a 0. The remainder is 0, so it is perfectly divisible. So that's why 4764 is also perfectly divisible by 4. Now let us just have a look at another example. 88,123. So we have to look at the last 2 digits, 23. Now if the last digit is odd, then it will of course not come in the table of 4. So this number, without even looking at it, we would just say it's not divisible by 4. Now, so we need to have a look at the last 2 digits. Moving on to the divisibility rule for 5. What is the divisibility rule for 5? If a number ends with 5 or 0, like 25 ends with the 5, divisible by 5. So it should just end with the 5 or a 0. Now 70 ends with a 0, divisible by 5. 335 ends with 5, divisible by 5. 7225 ends with 5, divisible by 5. 84,321 ends with a 1, not divisible by 5. Now moving on to the divisibility rule for 6. What is the divisibility rule for 6? If a number is divisible by both 2 and 3, it should be divisible by both 2 and 3. So now we are going to check. Suppose the number is 60. Okay, let's take 60. So 10 with a 0, it is divisible by 2. 6 plus 0, 6, divisible by 3. So it is divisible by 6. Now let us have a look at another number like 72. Ends with the 2, so divisible by 2. 10 plus 2, 9, it is divisible by 3. So this number is divisible by 6. Let us have a look at another example, 414. So 2 and 3. Ends with a 4, divisible by 2. 4 plus 1, 5 plus 4, 9. It is divisible by 3 also. So this number is divisible by 6 also. Now let us have a look at another number, 7575. Ends with a 5, not divisible by 2. But we see 7 plus 5, 12 plus 7, 19 plus 5, 24. So it is divisible by 3. So now if it is not divisible by 2 and but divisible by 3 or vice versa. So what should we do over here? If either of them are not right, that means even this is not going to be divisible by 6. It is necessary for both 2 and 3. So this is not divisible. Now moving on to the divisibility rule for 8. So what is the divisibility rule for 8? Let us take an example. 8024. What should we do over here? Let's see the last 3 digits. The last 3 digits. Yes, we need to check the last 3 digits. So the last 3 digits are divisible by 8. So then the whole number is divisible by 8. So over here 24, we know that 3 8s are 24. So this is perfectly divisible by 8. Now let us have a look at another example. 7232. So we need to check 232 if it is perfectly divisible by 8. Now over here I'll give you a small tip. That is, if the hundredth place is even. If the hundredth place is even, then only this will work. Then just have a look at the last 2 digits. If the hundredth place is even, then just check the last 2 digits if it is divisible by 8. So 32. So 32 is perfectly divisible by 8. So 7232 will be perfectly divisible by 8. But this works only if the hundredth digit place is even. Now so this is the divisibility rule for 8. Now moving on to the divisibility rule for 9. So what is the divisibility rule for 9? Like suppose the number is 162. So we need to again do the sum of the digits. So it is exactly the same like 3. 3 and 9 are the same. 1 plus 6, 7 plus 2, 9. But over here, the number should be divisible by 9 and not by 3. Because this is the divisibility rule for 9. So 1 plus 6, 7 plus 2, 9. 9 is perfectly divisible by 9. So of course, 162 is going to be perfectly divisible by 9. Let's have a look at another example. 756. 7 plus 5, 12 plus 6, 18. 18 is perfectly divisible by 9. So 756 is perfectly divisible by 9. Now 2421. 2 plus 4, 6 plus 2, 8 plus 1, 9. As this 9 is perfectly divisible by 9. So 2421 is also perfectly divisible by 9. So now if our number is 3333. 3 plus 3, 6 plus 3, 9 plus 3, 12. 12 is not perfectly divisible by 9. So even this is not perfectly divisible by 9. Now moving on to the divisibility rule for 10. The divisibility rule of 10. 10 is extremely simple. Let us have a look at the table of 10. You'll understand the pattern. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And we can keep going on and we will come with 110, 120, 130 and so on. So all the numbers end with the 0. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And all the other numbers that come in the table of 10 will also end with 0. So if the number ends with a 0, then the number is divisible by 10. Simple, right? Like 70 ends with a 0, divisible. 2520 ends with a 0, divisible by 10. 3570 ends with a 0, divisible by 10. And 2575 ends with a 5, not divisible by 10. Because it ends with a 5 and not with 0. Now, you might be wondering, why do we need these divisibility rules? What is the use of memorizing them? Is there any use of them? Now let us just understand the use of divisibility rules. So now we are going to understand why do we need divisibility rules? Why we need them? So the reason we need them is related to real life. Suppose it's your birthday. And you have 9 friends. You have 9 friends. You want to give each of them chocolates. Now, once we give to friends, we have to, of course, you have to divide amongst them equally and not give one more, someone 1 less, someone 2 more, someone 3 less, because that's not good. So we need to check the equal. So now, if he goes to the shop and finds 4 packs. So one has 110 chocolates, one has 90 chocolates, one has 100 chocolates, and one has 123 chocolates. So now, which pack should he buy so that he can divide amongst his friends equally? So we can use the divisibility rule for 9 and use it. So let's start off from here. 1 plus 2, 3 plus 3, 6. So 6 is not perfectly divisible by 9. So this is not the answer. 1 plus 0, 1 plus 0, 1. So this is 1. 1 is not perfectly divisible by 9. He should not buy this. 9 plus 0, 9. 9 is perfectly divisible by 9. So he can buy this pack. And so he should buy this pack. And now if we can just check over here. 1 plus 1, 2 plus 0, 2. 2 is not perfectly divisible by 9. So even this also he should not buy. This is the best pack that he should buy so that he can divide amongst his friends equally. So divisibility rules help a lot for real life. We need them. So hope you understood the divisibility rules and the need for them in real life. Thank you.